Dear students, in the last class we have seen relations and we have done exercise also. We have finished that exercise 2.2 exercise. Afterwards, we have to see functions. Okay, functions will be the last concept in this chapter. But afterwards, miscellaneous exercise also will be there. But let us understand functions. What are functions and all. Okay. Until now we have seen sets in the last chapter. Then in this chapter we have seen um, Cartesian products, ordered pairs. Based on ordered pairs and relations have come. Based on relations only these functions also will be there. Okay. Let us understand function first. What is function? Okay. Function is a special type of relation. Function is a special type of relation. See, when I say relation, automatically function is a relation. That's all. But all relations are functions? No. Conditions are there. What are those conditions and all we will see. Okay. When I say functions are relations, then automatically at least one thing should be subset of each. Then which will subset and which will superset? Function will be subset and relation will be superset. Say like this, shall I write? Why? Because function is a subset of relation. Okay. And what is original function? Let us understand with one diagram or arrow diagram. Say I am writing here. This is arrow diagram of function. Function A to B. Okay, 1, 2, 3, 4, 5, 6. Okay, relation is there. See, this is relation. We have not yet gone for functions. Let us understand first relation. Is this a relation or not? Why? Because this element is having relation with 4. This element is having relation with 5. This element is having relation with 6. This is a relation. Okay. Now I say this is a function. I say this is a function. Why? Because function definition what they have given, for every element in set A should have one and only one image in set B. Then that function is going to be called as, that relation is going to be called as function. Okay. In any relation, this is a relation. In that relation, every element in set A should have one and only one image. I already told 4 is image, 1 is pre-image, 5 is image, 2 is pre-image, 6 is image, 3 is pre-image. That means 3 element is having image 6. 1 element is having image of 4. Okay, these are images. Images are, if you make a set of images, range will come. Okay, range will come. Okay, you see, condition, what is that condition? Every element in set A should have one and only one image in set B. That relation is going to be called as function. That means first of all it should have relation. Without relation there is no function. Without relation there is no function. Function is a subset of relation. Okay, you understand now? You see here, every element means here all elements should occupy. But in relation, here some unoccupied elements will be there, even though they don't have relation with that another image, but that will be called as a relation only. But here in function, all the elements should have relation. Then each element should have only one image. This is the condition. First, let me write definition. Okay. In a relation, all elements from set A should have, or rather than all I will tell every. Why? Because that is good word. Every element from set A should have one and only one image in set B. Set A, set B. Okay. Now, set even I write, don't write also, capital letter belongs to represent the set. In a relation, every comes means you write only element, don't write elements. Every element from set A should have one and only one image in set B. You see here, this definition is satisfying or not? First, this is a relation. Every element from set A should be that function is that relation is called function. Okay, function we have not written. In a relation, first of all we should have relation. In a relation, every element should from A, set A, should have one and only one image in set B. One is having only one image. Okay, 2 is having only one image, 3 is having only one image. That is why this is a function. Okay, now I am going to draw 4 arrow diagrams, which are functions, which are not functions. We are going to understand the concept. Okay, then we will go for representation, notation, whatever it may be. Okay, see. Okay, what I am writing, here I am writing functions, here I am writing not function. Okay, you see how I am writing. Not a function. This is a relation, but not a function. Why? Every element must have only one image, but here the element 2 is having 2 images. Okay, but here only one image. That is why this is a function. This is not a function. But are these relation? Yes, these are relations only, but not a function. Okay. One more diagram I am going to write here. You see what is the function under. This is a function. Why? Because see, function definition told that there should be a relation and each element from set A should have one and only one image. See, 1 is having only 3 as image, 2 is having only 4 as image, 5 is having only 4 as image. That is why this is also a function. That means in image area only one image should be there for one element. For 2 it is 4, for 5 it is 4. Okay, that is why this is also a function. You see the definition what I have written. Okay, then what is not function also I am going to write another figure, another arrow diagram. Let me write another arrow diagram. This is not a function. Why? Because here element 3 doesn't have any image. But our definition says every element from set A. See, these are all set A's and set B's. Even if I write, I don't write also. This is set A, set B. Set A, set B. Set A, set B. Okay. We have come for our sets. Then we have come for relations. We have come to functions. Okay, all are interrelated, similarities. Okay, If you understand these four figures, then you have understood functions. See, function is definition. In a relation, first of all, relation should be there between two sets. In a relation, every element from set A should have one and only one image in set B. Okay? One and one only image. One is having only one image. One is having only one image. Two is having only one image. Five is having only one image. Okay? That is the function. But if you compare both of these, here 2 is having two images. That is why not a function. Element 2 is having two images. But here element 2 is having 4 as one image. That's all. Element 5 is having 4 as image. That's all. Okay, that is why this is a function. This is a function undoubtedly. This is not a function. Why? Because element 3 doesn't have any image. That is why this is not a function. Okay, you understand now these four diagrams. If you understood these four diagrams, then we go for function notation in depth of a little bit. Okay. Okay, you see now in relations we will show the relation notation as R. R of from A to B, relation from A to B. Okay, set R, say like this also we will show. X belongs to A, Y belongs to B. Such that we were showing in relation, not function. Okay. Now just we compare or we understand by seeing this. Okay, what is function? Function we represent a small f. Okay, function, but relation capital R. Function we represent with small f only, not capital F. Okay, and what else? Function like this also we represent. Function from A to B. Okay, and also function from X to Y. A to B, here also A to B will come. A to B. A, B belongs to F and F of A is equal to B. This also we write. Okay. A, B belongs to F, F of A. And F of A is equal to B means automatically if I write here, say F of X comma Y also I can write. And X comma Y belongs to F and F of X is equal to Y. This is very important. F of X is equal to Y. Okay. This is the notation. Notation we can say representation, not representation, notation. Okay. This you have to understand for functions. This was already understood in relation. Okay. This is for function. Okay. Function. Function from X to Y. Function A to B. Function A to B. Even if you write this also function A to B. Like ordered pairs only. In X coordinate A will come, in Y coordinate B will come. Or else X, Y like that only it will come. Okay. Here also domain ranges will be there. In function also domain range will be there. Domain will be there. Range also will be there for functions. For functions like relations, functions also have domain range. Okay. Like input output we have to understand. Input is domain, range is output like. Like I am telling, not exactly like. Okay. This is the concept behind the function. Now we go for individual functions and we draw graphs also. Okay. The terminology real valued function and real function, those terms we understand, then we go for graphs. Okay, you see, I already said domain will be there, range will be there for functions also. Okay, function is a relation. When relation is having domain and range, then automatically function also will have range and domain. See, if your function is having a range of subset of R, here R is real number. Okay, if a function is having range of subset of real numbers, then that function is going to be called as real valued function. Understand na? If your function is having range of subset of real numbers, see here also domain also will come, range also will come. If any function is having range as subset of real number, what are subsets of real number? Subsets of real numbers are natural numbers are there, whole numbers are there, integers are there, rational numbers are there. These are the subset of real numbers. If range is having natural number or whole number or integers or rational number, then that function is going to be called as real valued function. Okay, that is a real valued function. Then what about domain? If domain also a subset of real value, then that function is going to be called as real function. Real valued function, real function. Okay, real value means what? Output is equal to outside, that side, whatever, right side, whatever may be there, that is called value normally. Even in my logarithms basic also I have explained like that only. Okay, if range is having a subset of real numbers, that function is going to be called as a real valued function. But here you see domain and range both, if they have subset of real numbers, this is real numbers. Okay, here also real numbers, subset of real numbers, then that function is going to be called as real function. Okay, okay, let us see identity function. What is identity function? Identity function is y is equal to x or x is equal to y. Both are equal, x and y values are both are equal, that is going to be called as identity function. Identity function will be like this. See, 1 or 1, 2 or 2, minus 3 or minus 3. Okay, here x, y, both x is equal to y or y is equal to x. Okay, this is called identity function. And how we represent that identity function now, you see. Identity function normally what we say here, f of x is equal to x, and also said f of x is becoming y, we take y. Okay, in y coordinate f of x will come, that means y is here, x is input you are giving, output it is coming. If you give input 2, then output also 2 will come. Minus 3, 1, 1, like that it will come. This is called identity function. Okay. For identity function, what will be the domain and ranges? Graph we will draw. First, let us see. What is domain? Domain is R only. Real numbers only, no? See here, even if you give rational number also, irrational number also, same thing is going to come that side. That is why domain is also R, rational number is also, range is also R. Then this function is going to be called as real function. That's all. Range. Range also R. That means you can give anything. Anything matlab, anything means real number. Any real number, whole number, zero, integers, rational numbers, irrational numbers, whatever it may be, you can give, and the same thing is going to come as output or y or function, okay, gives the function result. This is called identity function. We will draw graph also. Okay, let us see how I am drawing graph. Graphs also important for the functions. X, y, x dash, y dash. Okay, then this is origin 1, 2, 3, 4, 5, 6, and here also 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. See, these numbers will go beyond. Okay. Now see x, y, say 0, 0, 1, 1, minus 1, minus 1, 2, 2, 3, 3, minus 4, minus 4. Like this will come now. Whatever x you give, same x, same value will come as output. If you draw the graph, see minus 6, minus 6, minus 4, minus 4, minus 2, minus 2, 0, 0, 1, 2, 2, 4, 4, 6, 6. That means straight line is going to come. Straight line is going to come passing through the origin. A straight line passing through the origin represent the graph of identity function. Okay, you see the values also. By seeing these values, you can easily understand the graph. Or by graph also you can understand. Okay, straight line passing through the origin will represent the identity function. Okay, see the values also. 6 minus 6 means minus 6. Plus 6 means plus 6. Both x coordinate, y coordinate. 0 means 0. This is the graph of identity function. Range, domain also I explained. What is the function also I explained. Okay, we go for another function. Okay, now let us understand constant function. Constant. Constant function. Here constant means output only. Output constant means that is called constant function. Let us understand first constant function concept. We will see how representation and all, domain and range. Then we go for graph finally. Okay. See, constant function will be like this. Say fx is equal to 4. Okay. Why? Because 4 is a constant. Have you seen my basic videos? Graphs also are there in basic videos. Please watch those basic videos. Those are very essential for you. Okay. Constant functions. Constant function means 4 is a constant. Fx also called as y. Y is equal to 4. That means whatever maybe you give values of x. 1, 2, minus 3, minus 4. But output comes constant only. 4 only. Here 4. See here. Y doesn't have any relation with x. Whatever you may give x, but y is coming continuously 4 only. Why? Because here not y is equal to 4x. Here y is equal to 4 only. Okay? That means, see, if I draw table, okay, if I give 0, 4 only. If I give minus 1, 4 only. If I give 2, 4 only. If I give 3, 4 only. If I give minus 6, 4 only. Why? Because y doesn't have relation with x. It continuously gives 4. This is called constant function. Now let us understand domain and range here. What are going to come? Domain, anything you are giving. That means real number. Or rather than equal to, you can write belongs to also. That is also not wrong. Even you can write belongs to or is equal to. Okay? Like this you can represent domain. But what about range? Can you write same real number? No. This only you have to write 4. Why? Because except 4 nothing is coming. Then why you are writing R? R means several numbers are there. Okay? R is a broad. Real numbers are broad. But here 4 is very narrow. Only one element is coming 4 as output or range. Okay? That is why 4 will be the range for this function, constant function. Here 5 is there, range will come 5. Okay? You understand the concept? Now we draw the graph also for this function. You see, I am giving -6, but it is coming 4 only. I am giving -2, but it is coming 4 only. I am giving 3, but it is coming 4 only. I am giving 6, it is coming 4 only. That means if you draw the graph, okay, if you draw the graph, straight line will come, parallel to x-axis will come. Okay, straight line parallel to x-axis, constant function. The value where it is coming and all depends on the higher value. Okay, output value, output, whatever it may be. Okay, this is a constant function. Constant function, what is constant function? I have explained you, and I have told you domain and range also, and I have drawn the graph also. Okay, then we go for next graph. Okay, next we understand polynomial function. Polynomial function. Okay, see, in basic classes also, or in 10th classes and what is polynomial we have understand. Okay, polynomial represent some x square or what normally x square, x cube, whatever it may be, like that functions will be there. Let us write and understand polynomial function. Say it will be like this: a0 plus a1x plus a2x square plus dash 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 plus an x to the power of n. Like this will be their polynomials. Here a is a constant and x is, see here a constant, here x is a is, a1 is coefficient. Okay, coefficient. Normally if x it is not having x, then it is going to become constant, or else it is coefficient. Okay, now you understand here there are some conditions. N must be non-negative integer. Non-negative integer means what? Integers, you know, integers is having -infinity to +infinity. 0 will be there, positive will be there, negative also will be there. That means non-negative integers means these should not be there, but positive integers will be there. 0 also should be there, 0 also may be there. N, you understand, na? If x power 0 comes, automatically what will come? 1. Then a0. That means even constant function also polynomial function only, if you observe clearly. Okay, concept is like that, you have to understand. Okay, now like n, they have given condition for a0 also. For a also rational number, sorry, real number. A belongs to real number. A belongs to real number means here a may come √2 also. You understand, na? √2 also. Why? Because see here they have not mentioned that this should come integers only or positive integers only. even minus also they may come. Okay, 2-3 polynomials functions I am going to write, then you compare, and what are not polynomial function also I will write 1 or 2, then you can understand. Okay, see here, 3x square plus 2, this is a polynomial function. See, all are these functions means fx I am writing. Okay, this is a polynomial function. Okay, why? Because see, this is a is a real number. Okay, x to the power of n is a non-negative integer, okay, and even you can write fx is equal to minus root 2 x. This is also polynomial function. Why? Because see, x power 1 is there, nothing is there means 1 is there. Okay, this condition okay. Even a also belongs to real number only. Okay, see, it may be rational number, negative rational number, but it contains real number only, na? Okay, what is not a function? These are polynomial functions. What are not polynomial functions I am showing you. X power 2 by 3 plus 6. This is not a polynomial function. Why? Because see, here nothing is there means a1, but a1 means real number only, okay, but for a condition it is okay. But what about for x condition, n, x power n should be negative, non-negative integer. See, here non-negative is there, but it is not an integer, it is a rational number. You understand, na? A rational or irrational, whatever it may be, it is a not a non-negative integer. Okay, why? Because integer means fair. It may be minus, it may be 0, it may be positive. Negative, 0, positive, fair figure should come. 2 by 3, 1.6, like that should not come. That is why this is not a polynomial function. Okay, now if you understand these polynomial functions, we go for one polynomial function. Let us go x square. X square only we will draw the graph. We will write and we will draw the graph. Okay, see. Okay, here I am writing fx is equal to x square. Is this a polynomial function? Yes, definitely polynomial function. Why? Because see, here a is 1, real number. X to the power of n is 2, non-negative integer. Okay, that is why this is a polynomial function. Okay, see, let us make one table, say x, y. We came to know that we can give any input, real number. Okay, these are all real functions or real valued functions only we are discussing. That is why real numbers only we can give. 0 we can give, minus 1 we can give, 2 we can give, minus 3 we can give, 4 we can give. Okay, okay, what will be the output? You see, fx is equal to x square means y is equal to x square. I already said fx you can take as y. Why? Because x, fx, x, y will come in coordinate, ordered pairs. Okay? Okay. Now you see, if you give x, automatically x square also will become 0. 0. If you give 0. If you give minus 1, it will become plus 1. If you give 2, it is going to become 4. If you give minus 3, it is going to become 9. If you give 4, it is going to become 16. Okay, these are the values we are going to get. Okay, now you write domain and range. Domain belongs to R, is it correct? Real number, it may be integers, rational number, irrational number, whole number, natural, whatever it may be. Domain will be range. Domain will be real number. Okay. Now you observe range. What is coming? Range. Is it correct? In range, anything negative natural number, negative integers or negative something is coming, irrational number? No. That is why for polynomial, for x square function, the range is positive real number. Okay, it may be rational or whatever it may be, but all positive will come. That you have to understand. This is range. Okay. Now we draw the graph also. Okay. See, if I take x 0, 0 will come. If I take minus 1 x, then plus 1 will come. If I take minus 1 plus 1 will come. If we take 4, 16 will come. If we take 3, 9 will come. If we take 2, 4 will come. If we take minus 2 also, 4 will come. Minus 3, 9 will come. Okay. Minus 4, 16 will come. All positive only. Y value always positive. Y negative will not come in square function, x square. Fx is equal to x square. Okay. Now if you draw the graph will be like this. Okay. Graph will be like this. This is a graph of x square. See, polynomial function x square, x cube, several are there, but I have drawn only for x square. We go for some other functions. In polynomial, different type of polynomials we did not see. One polynomial we have seen, that is x square. Okay. Now we understand the graph of this. Okay. Shall we go for another function? Okay. But here these are very important. You see, domain R, but range is positive R. That you have to keep in your mind. Okay, now let us go modulus function. Modulus. Okay. Let me write modulus function. This is very important. Modulus function. Okay, first we understand here, rather than graph we go for last. First we understand function here, we will draw domain, range, whatever it may be. Finally we go for graph. Okay. Okay. You see what I am writing and all. Modulus function representation is like this. Okay. This is a representation of modulus function or notation or whatever it may be. This is modulus function. Okay. Now say f of x is equal to mod x, that is equal to, see, it is x comma, when x is greater than or equal to 0, it is minus x when x is less than 0. First you understand what I have written, then we will discuss. First you understand. Okay. What I have written, see, symbol I have given, symbol or notation, whatever you may call, modulus function symbol or notation is this one. Modulus function you have to show like this. F of x is equal to x, but when x is greater than or equal to 0, minus x, x is less than 0. See, I want to tell you one thing here. Modulus function, you know, I am writing here. If you give 0, 0 will come. That means 0, 0, x, 1, or f of x. If you give 1, 1 will come. That means 1, 1. If you give minus 1, 1 will come. Minus 1, 1. If you give minus 2, 2 will come. Minus 2, 2. If you give 3, 3 will come. 3, 3. See, these are the modulus functions we have learned until 10th class. Okay, modulus function means this one. Modulus function means output will be positive only, not a negative. See, output all positive only will come. Even if you give negative integer or negative value also, but positive only will come. This we came to know. Okay, but we have learnt up to 10th class only input output type only. But what about function? Here we are learning function. See, this is an fx. Function box. We are giving input minus 3, but it is giving output 3. Okay. But what function is doing, that we have to understand. Here function, what it is doing? Function, it is doing whatever the input you are giving, it is analyzing this function box. What it is doing? It is analyzing whether it is x is greater than 0 or equal to 0. Okay. Then you make it the same x. Okay. What about x if less than 0 comes? Then it analyzing what it is doing. It is putting minus before x. You understand, na? So that final output should be minus of minus x. Minus of minus x. Then automatically x will come. This thing function is doing. Function we are learning function. We are not learning input output only. Input output also we are learning, but function, input output. But what function is doing? Function is doing this. Several students will get confused here, sir. Why you are writing minus x? Even x is less than 0. Then also x is coming positive only. Why you are writing minus x or negative x you are writing, like they ask. See, this is a function. What function is doing we are understanding. Function, what it is doing? Function, if you give positive integer also, positive going to come. 0 also, 0 will come. Negative 3, minus 3 also, but positive 3 is coming, means what it is doing? It is putting minus x, minus before your minus x. Finally plus x is coming. That means function is doing, if x is less than 0, automatically it is going to become negative value, but it is putting minus. Negative value with multiplication it is doing, and finally positive result is coming for you. Okay, this is the concept you have to understand. Then we go for graph also. Okay, you see graph also same thing. Let me write graph here, x, y. If you give 0, see same values. Here we are having values, no? Then directly we can draw the graph. 0 means 0, both. 1 means 1. Minus 1 means 1. Minus 2 means 2. 3 means 3. 4 means minus 4 means 4. Okay. Like this will come graph. Okay. This is graph of modulus function. Modulus function you have to understand first here concept. Modulus function notation or symbol and function values. These values are very important. X is less than 0, please write minus x only for function. For function, minus x only. When x is less than 0, minus x. But we are learning functions. If x is greater than or equal to 0, x. Equal to 0 means, if 0 means 0 only will come, na? If x is 0, 0. That's all. Okay. See here how results are coming. Okay. This is modulus function. Okay. Shall we go for another function? Okay. Okay. Now let us understand signum function. Signum function also one type. Afterwards, last one greatest integer function will be there. Okay. And then explanation about functions will be over. Okay. Signum function. In sets also I have told singleton set, like you might have understand singleton set. Singleton set. If any set is having only one element, A may be say 3, but number of elements are only 1. That is called singleton set. Single, S-I-N-G. Compare this with this one. Some similarity exists, that is why I am telling. Okay, this is set, but this function we are studying function. Okay. Signum function, there is no separate notation or something. Fx is equal to, say, 1 if x is greater than 1, greater than 0, 0. If x is equal to 0, minus 1. If x is less than 0. Okay, this you have to understand. This is the signum function property. That means, see, if you give input or domain greater than 0, but output is only 1 will come. Even if you give 200 also, but output 1 will come. Even if you give 3 also, output will come 1. Even if you give 0.5 also, output will come 1. It should be greater than 0. If you give greater than 0, automatically 0.25 is also greater than 0 only, na? If you give 0.25 also, 1 will come. But if you give minus 32 also, it gives minus 1 only. If you give 0, then it shows 0. This is called signum function. Okay. Let me write this table also, how these are coming. X, Y. Okay. If you give 0, 0 will come. Minus 1, minus 1 will come. Minus 32, minus 1 will come. 0.5, 1 will come. 3, 1 will come. What you understand? That means if it is greater than 0, see, this is greater than 0, this is greater than 0, 1, 1 will come. If you give 0, 0 will come, that is over. Then you come to negative, x is less than 0, if you give minus 1, minus 1 will come. But even if you give minus 32 also, minus 1 only will come. That means it gives positive 1, negative 1 or 0. That's all. That is the specialty of this signum function. Okay. Now we write domain and range. I think in last function, modulus function, domain and range we have not written. There, modulus function, I am talking about modulus. Modulus function, domain is R, but range is, I said, I think, positive R, that's all. Why? Because in modulus function there will not be any negative numbers. Okay, positive function, positive real numbers. Okay, that this is for modulus function. Now we rub it. This is a singleton function. Singleton function, you tell domain and range. What is there? By seeing this graph, domain will be R, real number. Why? Because real, national, rational, irrational, whatever you may give input. Real numbers you can give input. Okay, domain you know very well. But what about range? Range also real? No, you have to write like this, range. See, minus 1, comma 0, comma 1, close. This is the range. Why? Because these three only will come in the range. It may come 0 or it may come minus 1 or it may come 1. That's all. Rather than these three figures, nothing will come for output or range. That is why signum function, domain and range should be, see here domain belongs to R also you can write. Domain belongs to R. Domain belongs to R. This is also correct. Exactly this only will correct. You can take any real number. Okay. And range will be, range equal to you put. Domain belongs to, but range is equal to you put. Why? Because these are fixed figures. Rather than these three figures, these three digits, nothing is going to come. Okay. Now I will draw the graph. You observe how I am drawing the graph. Okay. See, if it comes 0, original exactly 0 will come. That means you close the bubble in 0. I am closing the bubble. Closed interval. Okay. If I give more than x is greater than 0, that means x is greater than 0, x is less than 0. Here is there, no, x dash, minus x, plus x. Input I am talking about. Output let us see. If greater than 0, if I give what it is going to become, minus 1, plus 1 it is going to come. But here you keep open interval like this. That means it can go anywhere. Even if you give 6 also, like this only will come. Okay. But this bubble you keep open. Here closed. Why? Because x equal to. You see, x equal to. X is greater than. If x is greater than, equal to not there. That is why you give open bubble. Here also you give open bubble. like this. You understand now why I have given open in 1 and minus 1. 1 minus 1 equal to symbol is not there. X is greater than 0, X is less than 0. That is why open bubbles, open interval. Intervals also I have told you in first chapter, sets. Now we are in relations and functions, second chapter. But at 0 equal to symbol is there. 0 equal to symbol is there. That is why closed bubble. This is closed bubble. Okay. This is graph for signum function. Signum function I have explained values. Signum function there is no notation like mod x or something. Okay. This is not important. This table. But domain range you have to keep in mind. Graph also you have to keep in mind. Signum function. Okay. Plus 1, minus 1. 0, closed interval. This is a signum function. Last function is there, greatest integer function. That also we will learn. Okay. Okay. See, the next function is greatest integer function. What is greatest integer function and all we understand, and we will see domain and range of these functions also. Okay. You see, in our earlier classes or basic classes or even 9th, 10th and all, we came to know LCM, GCF, HCF. HCF is also called GCF, greatest common factor or highest common factor, LCM. But for namesake least is there, but this figure will be bigger. For namesake highest is there, but this figure will be lesser. This concept you understand, na? Least common multiple, LCM. LCM will be bigger than HCF always. Like that, for writing sake we write greatest integer function, but less value you have to take. That you have to keep in your mind. Okay. What less value and all you understand here. See, first you know integers. Integers. Here I am writing integer means you have to know about integers. Integers. Integers we already know. Minus infinity to minus 3, minus 2, minus 1, 0, 1, 2, 3, it will go up to plus infinity. Integers are fair figures, no fractions, no 2 by 3, no rationals. Okay, fair digits, I can say digits, fair digit. 0 is a fair digit, minus 2 is a fair digit, 3 is a fair digit, fair figure. Okay, those are called integers. Okay, see, if I write a number like this, 1.9, greatest integer function will take it as 1 only. Why? Because here it will split integer and fraction. 1 plus 0.9. Here integer is what? Integer is 1 only. It will take 1 only. You understand, na? Say, if I give minus 3.4, it will take minus 4 only. Why? Because if you see here, minus 3.4 will come between minus 4 and minus 3. But here, lesser digit is what? Less value is minus 4. You see, from left to right, values are going to increase. Minus 6 is less than minus 2. Minus 2 is bigger. 0 is bigger than minus 1. 1 is bigger than 0. 6 is bigger than 3. 4 is greater than 4. That is why minus 3, minus 4, minus 3.4 is there. Then small value is minus 4 only. Then minus 4 is going to take this function. This function I am talking about. Okay. Here minus 4 is there. You see minus 4. Like that you have to understand this concept. Okay. That means if we take only integers, it will split the figure. Integer part only it will take. Then automatically, if you split the figure, automatically integer part will always come less only. Now 1.99 also 1 only will come. 36.33, 36 only will come. Minus 29.7, minus 30 will come. Why? Because see, minus 5.7, then minus 6 only will come. Why? Because it is between minus 6 and minus 5, but less value is minus 6. Here lesser digit lesser integer is minus 6. Integers are minus, negative, 0, positive, all are there. Okay. Now we write here the concept here, those concepts also. Okay. F of x is equal to, say I am writing 0 if x is between 0 and 1. You understand na? That analogy you see. If x value is between 0 and 1, it will take 0 only. 0 only it has taken. 0 it has taken means it has made equal to 0. That is why here I have put equal to symbol. Less than 1. What if it is 1 or greater than 1? I am telling. See, x is greater than or equal to 1 but less than 2. It will take 1. You understand na? Why? Because see, it may be greater than 1 but less than 2. That is why it will take 1 only. 1 only. Okay. Now third also we will see. What if it is having x is greater than or equal to minus 2 but less than minus 1. Minus 2 is smaller here. Minus 1 is bigger. You see here. Minus 2 is smaller. Minus 1 is bigger. The range should be minus 2 to minus 1. Then it will take minus 2 only. That is why minus 2 equal to minus 2. Okay. What if it is greater than 2 or over? Na? Yeah, okay. Greater than 2 but less than 3. It will take 2. Okay. These are the sorry. These are the concepts you have to understand. Okay. Here also you see what is the domain and what is the range. Domain belongs to real number, we can say easily. Why? Because see, 1.99, 1.33, something, even irrational numbers also you can keep as a domain. But what output it is giving? Integers only. That you have to keep in mind. Okay. It may be minus also. Minus, negative, or even 0 also. You see, 0 also coming, 1 is also coming, minus 2 also coming. That means all integers only it is coming. That means greatest integer function's range is integer. In question, they don't ask domain. They know that real numbers, any real number they can feed as an input. But output what is coming? Range. Range only they ask. That is why greatest integer function, the range you have to keep in your mind. Z. Integer. Why? Because integers only will come as output. That is the concept of greatest integer function. Okay. It will take greatest integer means it will split the number. Integer part, rational part. We can say remaining this 0.9 is rational or irrational, whatever it may be. Integer part, rational or irrational part, it will split. It will take only integer part. That is this greatest integer function is doing. Okay. Let us draw the graph also. You see how I am drawing the graph. Okay. Okay. See, up to 0 to 1, 0 will come and 0 is closed interval. Here equal to is there. That is why up to 0 I am writing like this. You see. This is open bubble. This is a closed bubble. Okay. From 1 to 2, this is closed bubble 1. You see, 1 to 2, 1 is closed, 2 is open. 2 to 3, 2 is closed, 3 is open. Okay. Like that here also you can come. Say minus 1. Say for 0 is over, yeah, 1. 1 to minus 1. Okay. Then 1 to minus 1, this is closed, this is open, minus 1 is open. 0 is open. Okay, minus 1. Minus 1 I have not written, minus 2 also you can see. See, same thing. Even if comes years also. this is closed, this is open. Here this is closed, this is open. If greater than -2 but less than -1, greater than -2 but less than -1, -2 will come. -2 closed interval, -1 open interval, open bubble. This is the graph of greatest integer function. Okay, greatest integer function range is very important. Okay, only integers are going to come. Real numbers are not going to come. Real number only, integer also real number only, but remaining part of the real number is not going to come. Only integer is going to come. Okay. ऐसा दो ब्रैकेट के बीच में x डाल दिया तो ग्रेटेस्ट इंटीजर फंक्शन है. That you have to keep in mind. Okay, then in next class what we do some algebraic operations of functions are there. That along with exercise also we will do in that class. Now we have finished about functions. Okay, thank you very much.